Hi folks, Mr. Long here. I'm going to do another screencast on calculus tangent problems with quadratics, and I'm going to go through type 2. And in type 2, what we do is we give you an equation of a function, right? An equation of a function, and then what we do is what I do is you have the equation of the function, and I give you the slope of the tangent. Okay, the slope of the tangent. That's it. And then from there, you've got to figure out the location, the point of tangency. So remember, the point of tangency is the a value. So I want to start out with a bit of a rough sketch. Okay, a rough sketch. So now I put here, remember the x value of the vertex is negative b over 2a, but you know what? Since we know calculus, we might as well use it. So with the tangent slope function, right? So there's my original function right there. If I get the tangent slope function and then I set that equal to 0, well, that means the tangent slope is 0. Well, where's the only location where the tangent slope is 0? At the vertex. So I take that, and the tangent slope function, if that's negative 1x squared, negative 1 times 2 is negative 2, and then x to the 1, so negative 2x. And then I look at this last part, the linear part, 4x plus 8. Well, what's the slope of the line 4x plus 8? Just 4, so plus 4. Okay, so then I solve that equation because I'm setting the tangent slope equal to 0. And so that means it's at x equals 2, that's where the vertex is. So if I notice, let's go back to the original equation. I know the y-intercept of the parabola was plus 8. I know the vertex is at x equals 2, and I know it's a negative, it's a sad parabola, so it's opening down, it's frowning. So let's go ahead and draw a quick little sketch of it. So I would know that it goes through there, and then it comes to a vertex there and comes down. So that's what the parabola looks like. And I really do think it's a good idea to show those rough sketches on a test or on an assignment. It lets me know that you're able to understand the question and judge whether or not your final answers are reasonable. Okay, so now let's go back and oh, by the way, that's one thing I did want to address with you is if you think about it, we're finding out when the slope of the tangent is negative. Well, where will the slope of the tangent be negative? Is it going to be on the left side of the parabola or the right side? Well, to me, the tangents here are going to all be positive. The tangents on this side are negative. So we know our tangent, if we've done things right, the tangent's going to be somewhere over here, right? So it's going to go straight in that way, straight in that direction. Okay, so that's what our tangent will look like, and it will have a slope of negative 6. Okay, negative 6 over 1 will be the slope of the tangent, which remember is the value of the tangent function, the tangent slope function. Okay, so let's go back over to all the algebra now that we're going to look at. So here we go. So once again, we don't know the a value. We know that equation of our original function, and we know that that right there is negative 6. Well, what is that negative 6? That's the tangent slope. The tangent slope is f prime at a. We just don't know what a is. Okay, so f prime at a is worth negative 6. The slope of the tangent is negative 6. So what I do is, there's my original function, and I figure out what the tangent slope function is, right, which we already did to get the vertex on the other side. Okay, so there's our tangent slope function, and I set that equal to negative 6 and solve. So if I solve that, right, and again, here's where you might want to pause it and actually solve these equations, right? I'm not going to take the time to tell you how to solve a linear equation from grade 9. I wouldn't want to bore you, okay? So x equals 5 is what that works out to. So if x equals 5, which is our a value, right? That means our a value of 5. That's the location where the tangent slope is negative 6. So I go over to here, and I know then that that tangent is at 5. Okay, that's our a value. Okay, our tangent is at 5, and that's the a value. Okay, so that's where I know the tangent is. So now it's just a regular tangent question after that. All I had to do was find out the location where the slope was, the slope of the tangent was negative 6. So let's go back over to this side. And now I know that f at a is f at 5. And I need to substitute that 5 into the original equation to get the y value, which I do right there. F at A works out to 3. Whoops, works out to 3. And from there, now I'm just going back to using that tangent equation. So there's our straight line equation of the tangent. And f prime at A is just the slope of that tangent line, which we knew right off the start was -6. Then I have this x minus a part, which is, for in this case, is going to be x minus 5, because our a value is 5. And then I had to figure out f at A, which I did above, and that was 3. Okay, I plug all that in, and I can expand through and simplify, and I would end up getting the tangent slope is -6 plus 33. And if we look, if I'm to go over and look at the picture, right, that means that from this picture that this y-intercept up here, like if I'm looking all the way down there, that y-intercept is 33, okay, which given the shape of the graph, and by no means is it's just a rough sketch, but it's very reasonable, right? Because it's sloping down, which means it has a higher y-intercept than 8. So that's a nice check and see if things are reasonable. Okay, folks, so again, rewind, look that over. That's your type 2 tangent problem.